Hello guys, today we're going to finish 3.5 rational functions and their graphs. Let's take a look at example 5. We need to graph this rational function. Okay, step 1 we're going to check is it symmetry. So if f of negative x equals to f of x, then we're going to have y-axis symmetry. Also is even function. If f of negative x equal to negative f of x, then we're going to have origin symmetry, which is an odd function. We have done this before. We're just going to find what is f of negative x. We're just going to replace your x with negative x. So that will be 2 times negative x minus 1 over negative x minus 1. So then we're going to simplify this. That will be give you negative 2x minus 1 over negative x minus 1. We're going to take negative out. So that will be 2x plus 1. So here, same thing, we're going to take a negative 1 out, and then we're going to have x plus 1. So then they're going to be canceled out, so we're going to have 2x plus 1 over x plus 1. So the reason why we take negative 1 out is just easy for us to compare f of negative x to the f of x. Okay? If you look at this, f of x is equal to 2x minus 1 over x minus 1. So that first is going to tell us f of negative x is not equal to f of x, right? So that means we can say this is not y-axis symmetry. So what if we're going to compare to negative f of x? So that is not working either. So I'm going to do is I'm going to find the f of 0. That will be 2 times 0 minus 1, and then 0 minus 1. This will give you negative 1 over negative 1. That will be 1. So that means 0, 1 is your y-intercept. Okay, step 3. To solve p of x equals 0 to find the x-intercept. What is the p of x? It's basically just your numerator. So at the beginning, we had something like this for rational functions. So my numerator in this case, that will be 2x minus 1. Set it to 0. And then you're going to find x equal to 1/2. So we can rewrite this as your 1/2, 0 is your x-intercept. Step 4, solve q of x equals 0 to find the vertical asymptote. Remember, q of x is just the denominator. So in this case, our denominator is just x minus 1 equals 0, which gave you x equals to 1. That's your vertical asymptote. Step 5, find the horizontal asymptote. So let's take a look for step 5. So if you look at the original, okay, let's take a look. If you look at the original function, so here we're going to have the degree of the numerator is 1. The degree of the denominator also is 1. Okay, so that means your n is 1, your m is also is 1. So that means this whole thing give you n equals m, which implies my horizontal asymptote is just going to be the leading coefficients. Maybe I'm going to write it right here, just kind of remind you what was the original. So your leading coefficient for the numerator is just going to be 2. The leading coefficient for the denominator is just going to be 1. It just gives you 2. So which means the y equals to 2 is the horizontal asymptote. Step 6. Plot at least one point between and beyond each x-intercept and vertical asymptotes. From these previous steps, we actually found our x-y-intercepts and the vertical and horizontal asymptotes. So that is the first part. I'm plugging this inside this graph. If you look, I distinguish different colors, so you can take a look. And then what we're going to do is we're going to plug in some points. So if you look at here, we have vertical asymptotes, this orange color right here. So we basically want to, the simple way to say we're going to plug in some points to the left side, and then plug in some points to this right side is the vertical asymptote. So I'm just going to do some random points. You can use a little bit different. So I'm just going to plug in -2, okay? -2 to see what happens. We're going to plug in also -1. For my x, and then from here on the right side, this vertical asymptote, I'm going to plug in +2 and +4. So if you plug in this -2 inside this your original function right here, okay, So you basically just replace your negative 2 for your x and then do your calculation. So you're going to get around 1.6. You do the same process here. You're going to have here's 1.5, this is around 3, and this is around 2.3. So let's go ahead and plug in those points and then see what it looks like. Alright, that is how you graph this rational function. So go ahead to follow the steps you should get there. So step 1 is the symmetry. Step 2, you're going to find your y-intercept. Step 3, you're going to find your x-intercepts. And then we're also going to find your vertical asymptote, find the horizontal asymptote, and then plug in some points, from the left side vertical asymptote, the right side asymptote, and then see what it looks like. So this is how it works. Remember, on your tests and quizzes, you must show work. Okay guys, so make sure you know how to do it without your graphing calculator. Alright guys, here we have example 6. It's very similar questions. Okay, let's go ahead. We're just going to do step 1, 2, 3, okay? So remember, step 1 is checking is the symmetry. So all you're doing is just find what is f of negative x. I'm going to plug in negative x here. That would be 3 times negative x squared over negative x squared minus 4, which is to give you 3x squared, right? Because you are raised to an even power, you're going to get 3x squared. Again here, we're going to raise to an even power. Same thing, you're going to get x squared, and then we're going to have minus 4. Look at them, they're exactly the same, which means we're going to have a y-axis symmetry. So that is our step 1. Step 2, we're going to evaluate f of 0. We're going to plug in 0 here. That will be 3 times 0 squared over 0 squared minus 4. So here we have a 0 squared, that will be 0, multiplied 3, that will give you 0. 0 over negative 4, that will be 0. So that means you're going to have this 0, 0 is your y-intercepts. Then step 3, so we're going to set the numerator to 0 to find the x-intercepts. So in this case, it's pretty clear that just give you x equals positive negative 0, that would just going to be 0. So 0, 0 also is your x-intercept. So then step 4, remember we want to find the vertical asymptote by setting your denominator to 0. Okay, you solve this. You're going to get x equal to positive negative 2. So that means that they are the vertical asymptotes. And then step 5, so in this case, remember that is your n, okay, and then there's your m. So that means n and m, they both equal to 2. So we're going to say that n equals m, the whole thing equals 2. So that implies you're going to have the y equal to the leading coefficients of numerator, that will be 3. The leading coefficients of the denominator is 1, so that will be 3. So y equals 3, that will be your horizontal asymptote. So once we have all this information, step 6, all you have to do is just go ahead, plug in some points. So before I'm going to plug in some points, I'm going to go ahead, draw what we have so far. So we're going to have the x, y intercept, they all passing through this origin right here. So we also had the vertical asymptote is negative positive 2. We also have horizontal asymptote. Okay, that is something we want to do first. Once we have this, we're going to plug in some points. So here we have a vertical asymptote. We're going to plug in something between those vertical asymptote and beyond. It's going to plug in some points. I'm going to write table right here. I go ahead and plug in this. You can do it just inside your calculator. So you plug in your negative 3 inside your function and see what you get for your f of x. So now we're going to do the graph. So we're going to have something like this. Okay, so that is my graph. Okay, so also we're going to have right here, and then this side is the same thing as well. Okay, this is how you graph this. Remember, this is symmetry, y-axis symmetry. So here, if you fold this like origami, and then they should all fold it perfectly. Of course, I draw it by hands. There are some errors, but if you do this accurately, and then it should look like this. So that is how you graph rational functions. So here we have example 7, we're going to graph x to the 4th power over x squared plus 1. So again, this is very similar. Let's do this really quick. So we're going to figure out the symmetry. So we're going to have f of negative x equals negative x to the 4th power. Then we're going to have negative x to the 2nd power and plus 1. So that will give you x to the 4th power over x squared plus 1. So this whole thing means f of negative x equal to f of x. That means is the y-axis symmetry. And then step 2, find the y-intercept. Remember, so we're going to do this. F of 0, you plug the 0 in, and then that's going to give you 0. That means that is your y-intercept. Then step 3, you're just going to set your numerator to 0. That means your x-axis is 0, so that is your x-intercept. And then you set the denominator to 0 to find your vertical asymptote. So what happens here is, if you look, right, there's never going to have a case like this because any real number squared always give you a positive. That means there's no vertical asymptote. So then the step 5, you find the horizontal asymptote by using your n, in this case is 4, correct? That's numerator right there. And then your m is 2. So which means your n is greater than m. In this case, there's also means there's no horizontal asymptote. And then once you have this, and then you just can see, what you can graph so far, and then you plug in some points. So here we have all the information. We know we're going to have a y-axis symmetry. So we have the xy intercept, the both is here, the 0, 0 origin. So then there's no vertical asymptote and no horizontal asymptote. All you have to do is you're just going to plug in some points. So since we have xy intercepts is right here, we're going to plug some points on this side. So we're also going to plug some points on the positive side. So I'm going to use -2 and then -1, and I'm going to plug in 1, 1. So if you plug in those points, so you're going to have something like this, alright? You're going to have 16 over 5, you're going to have 1/2. So here's also going to be 1/2 and then 16 over 5. Then once you have this, so you're going to plug in those points here, and then you're going to have your graph. So here we're plugging the points. So 16 over 5 is just around 3.2. So this is 3, right, 2, 1. Okay. Once we have these 5 points, I can just go ahead do the graph. That is how you graph them. So let's look at example 8, finding the slant asymptote. For this type of questions, if you look here, the degree of the numerator is 2, the degree of the denominator is 1. So basically that satisfies the slant asymptote definition given to us. So what we're going to do is, step 1 is very simple process, okay guys? If we have something like this, all you have to do is, we're going to go ahead, just use synthetic division, which is the easiest one. If you like a long division, you can use a long division as well, okay? So synthetic division, right, tells us we're going to put the 3 right here, okay? So here we're going to have 1, -4, and -5. So once we do this, we're going to drop 1, just in case you forgot, and multiply, and then we'll add, okay? That will be -1. So we'll multiply it one more time, and then we're going to add, so that'll give you -8. Remember, this is your remainder, okay? This is your constant term, and this is your x. So I can rewrite this as f of x equal to x squared minus 4x minus 5 over x minus 3. This is just going to be equal to, remember this is my x term, that will be x minus 1, then plus my remainder is -8 over x minus 3. So you've done this previously for dividing the polynomial. If you look right here, what is the slant asymptote? The slant asymptote is just this portion. Let me go ahead and highlight this. This is the part is our slant asymptote. So because here given to us, so basically right here, this part, alright? The slant asymptote is just going to be y equal to x minus 1. So you're done here, because all they want you to do is just finding the slanted asymptote. This question didn't ask you how to graph it, but if we have a graph, this is going to look like. Thank you for watching the video. I'll see you guys next time.